Hello, everyone, and welcome back to another episode of Indexer Office Hours. Today is the 11th of October, and this is Indexer Office Hours 80. If anyone is new to Indexer Office Hours, this is the town square for indexers where ecosystem participants come together and discuss the most important and relevant topics for indexers. Today's conversation will be broken down into 4 segments: opening remarks, repo watch, protocol watch, and we have a workshop that we're going to be covering with Chris and Anna all about Launchpad. We love participation, so at the time that we open up for Q&A, we'd love to hear from you either in voice or in chat, so please feel free to unmute your mic and join the conversation. Just as a reminder, this is going to be recorded and distributed onto public channels like YouTube, so please bear that in mind. And with that, let's get into today's conversation. So I'm going to start off with opening remarks and give a shout out to the latest GRT IQ episode. I'll be very quick. It is 85 with 𝗨𝘀𝗲𝗳𝗂𝗧, who is the CEO and co-founder of 𝗨𝘀𝗲𝗂𝗟𝗶 Analytics, a data solutions platform built upon the graph that provides serverless on-chain data infrastructure and services for data teams, analysts, and engineers. So in that conversation, Nick and 𝗨𝘀𝗲𝗂𝗧 covered a variety of topics, anywhere from clean energy, the crypto industry, space exploration, UFOs, and finally the graph and Web3. And Nick described 𝗨𝘀𝗲𝗂𝗧's descriptions of the blockchain ecosystem as the best you'll ever hear. So if you're interested in hearing his breakdown of blockchain and his views, definitely recommend checking out that episode, which is linked in the chat. Thank you, Nick. And with that, I'll hand over to Anna, who's going to take us into Repo Watch. Take it away, Anna.
All right. Hello, everyone. And thank you, Abel, for handing this over to me. All right. So today on Repo Watch, we have quite a few updates. Let me just mute my, okay, cool. So on the execution layer client for 𝗟𝗏𝗀𝗀, we have had a new release. First of all, notice that the release versioning has changed from having a long release version to something like 2.27, which is the current release, and that's more in line with 𝗟𝗏𝗀𝗀𝗃 2. Now, this new release seems to break RPC daemon on when running in Kubernetes. So, so it has a known bug. The issue is linked in the agenda. So I would say please hold off upgrading to this release to 2.27.0 just because of the RPC daemon bug. In terms of other changes, they've also added some experimental light client CLI flag to run an embedded consensus layer client. Then we also have had a couple of new releases from Streaming Fast Get for BSC and Polygon. On the consensus layer client, actually, before I move on to the consensus layer clients, can I please ask, has anyone had any experiences with 𝗟𝗏𝗀𝗃, with the new version of 𝗟𝗏𝗃, other than the bug?
Working fine in production here.
Okay. And
been smooth on our side.
But you're not running it on Kubernetes, right?
Correct.
Okay, cool.
Yeah, we're not either. It's all bare metal.
Okay, cool. That's good to know. Thank you, everyone. Okay. So in that case, upgrade if you're not currently running. I think, yeah, upgrade if you're not currently running it in Kubernetes. Cool. So going to consensus layer clients, no new release on Prism. We have had a new release for Teku, that's version 22.10.1. It is a recommended upgrade because it contains quite a few bug fixes, included one that was unexpected rejected execution due to full task queue, and an issue with high CPU usage. It does have a lot of breaking changes. I will not go through them because they're very specific and not everyone uses 𝗨𝗂, but please make sure to check the release notes, the RepoWatch notes on the agenda. On Nimbus, so this is a recommended release for 𝗨𝗂. On Nimbus, no new releases. Same with Lighthouse. Moving on to the graph stack, we have had a new release, so version 0.28.2. Big warning with this one, all indexers are advised to migrate straight into version 0.28.2 and entirely bypass 0.28.0 and 0.28.1. This is because both of those versions have a bug which will cause subgraphs to stop syncing under some deployment configurations. And in terms of indexer service and agent, so we have a question: should MIPS participants also upgrade? Yes, so that you don't encounter the bug. Okay, indexer service and agent. New release, version 0.20.4. This is a pre-release. It has docs update. It has fixed a bug in its deployment worth allocating towards. It persists receipts with 0 fees. And it changes service to agent in the agent run command. Before I move into the next section, which is the new graph orchestration tooling, would anyone like to contribute in terms of experiences with GraphNode version 0.28.2 and indexer agent 0.20.4? We have Adam saying this release includes a change which will be necessary for closing allocations for no-sys subgraphs. And this is related to the GraphNode release. Chris is saying where GraphOps are running 0.28.2 and it all seems happy. Same with Jim. Okay. In that case, moving on to the last section, which is graph orchestration tooling. This is a section that was added last week. So we have StakeSquid, so Graph Protocol Testnet, Docker, and Graph Protocol combined Docker have not had new releases. For GraphOps Launchpad, you will finally see it today. But remember, it's still in alpha state until we have more people using it. We are using it in production. So in Launchpad, we have had on Launchpad Starter new updates to latest core, and we have added some sample sealed secrets release type. And we have also updated monitoring layer to persist data. On the Helm chart repo, all of the Nimbus, Nethermind, and all of the recent releases, recent changes to the execution layer clients and consensus layer clients have been updated. For Launchpad core, we have had a new release, which is 0.020. Again, that updates to latest Nimbus, Nethermind, and Aragon charts, and it has a restructure of some of the names of the namespaces we're using. I don't expect anyone to fully follow the last section, so I will ask at the end of the workshop if anyone has questions about this section of RepoWatch. I will hand over to Abel in case there's anything else to be said outside of RepoWatch.
I think you handle it pretty well. And I will say that for this week, we're going to skip on Protocol Watch. There's not much that's changed since last IOH. And before I hand it back to you, and I just want to say a big shout out to you and Chris for all your work on Launchpad. It's been an incredible journey and a very exciting day. And I'm looking forward to everyone seeing all the progress that's been made on Launchpad. So yeah, big shout out to you both, and I'll hand it back to you so you can take us into the workshop.
Thank you. All right, just give me one more second. All right, time to share my screen. All right, can everyone see my screen?
We can indeed.
Awesome. Well, welcome everyone to our much awaited intro to Launchpad. As Abel said, I also want to say a big thank you to Chris and the GraphOps team for helping work on this. This has been a major project. And thank you in advance for everyone who will be trying this project and supporting us. So the purpose of today's workshop is to introduce you to what Launchpad is from a bit from a theoretical point of view, from a hands-on point of view, as well as with some diagrams, as well as visuals. And so we have designed Launchpad to meet everyone's host orchestration needs and to be one-stop solution for indexing infrastructure. So before I talk more about Launchpad, the agenda for today is why Launchpad, what is Launchpad, a demo of a sample setup, and additional Q&A. Okay, so Launchpad is a set of functionality that allows you to set up host and network abstraction layers, to use declarative version control infrastructure as code, to use containers, use Kubernetes, and to be able to plug in whatever host you have come in, whether it is from something you're hosting in your garage, something you're hosting on VMs, or something you're hosting on public cloud providers. Now, if you're new to Indexer office hours and the MIPS program, and you just joined us, you might be completely confused. In that case, I would invite you to go back to some of our previous workshops about what it takes to run an indexer. So some indexer best practices. We have had a MIPS workshop on infrastructure orchestration and some things to think about before deciding how you're going to run your infrastructure. Some of those things were CapEx and OpEx. So CapEx being capital expenditures, being the initial cost that you spend on your setup, which applies mainly to running bare metal servers only. And then we talked about OpEx, which is the operating cost, which can be higher on some managed cloud platforms, can be very low on running only on bare metal, and it's a bit of a mixed bag when you are mix and matching some VMs that are renting with some bare metal or with some public cloud. So just to give you a refresher as to why we're talking today about this project we are calling Launchpad. please go back to those presentations. Okay, so in terms of what Launchpad is, it's a strong foundation for long-term multi-chain indexing, so that new indexers can take a small stack and then grow it, and be able to add more than one chain while being able to manage complexity. So what else is Launchpad? It is an opinionated client, opinionated set of tools that lives on your local machine, and that is layered over, like tools layer on top of another tool to provide a declarative workflows through all of the layers of your infrastructure. So for this setup, we will be using task file as the main tool that to define and run your tasks on your local machine. So by doing that, we are trying to abstract away some of the complexity of running all of the other tools. So for example, Helm file, which is a tool for defining and deploying Helm releases, Ansible, which is CLI for running declarative provisioning against hosts with SSH, kubectl, Helm, and SSH. So there's a lot of tools. We're using task file as an abstraction to make it easier for users to keep up with the structure of commands. And all of these tools are the ways in which you'll be interacting with the host machines. All right, so what else is Launchpad? So we said that it is an opinionated stack of software running on your host machines, orchestrated with Kubernetes, that provides core cluster functionality and everything you need to run a scalable indexer on the graph decentralized network. So in this diagram, you have your host machine, so you'll bring your own host infrastructure running on Kubernetes. And by virtue of running Kubernetes, you are then able to run all of these other applications that together form the application stack of Launchpad. So you can see that we have different layers. So the very first layer is the storage layer. The storage layer currently supports OpenEBS, OpenZFS, and LVM. Then we have sealed secrets, which is a functionality for storing encrypted secrets in your repo without issues, and then sealed secret controllers will decrypt that sealed secret in your cluster. We also have monitoring stacks, so we're using Prometheus, Grafana, and Loki for monitoring. Then we have Ingress, Postgres operator for the data that will be stored from our graph stack. And then we have Gnosis mainnet and ETH mainnet, as well as the graph stack. So this diagram that sort of shows you the different components. Now, I bet you're still wondering, what is it actually? Well, when we look at it from an actual structure point of view, Launchpad is, at the core of everything is two separate repos. So we have Launchpad starter, which is your starter repo. And once you have cloned it, it will become your private instance of infrastructure as code, which then you manage yourself. Now, Launchpad starter provides workflow and structure for mapping infra, and what is declared in there will be acting like your command center for your infrastructure. As part of Launchpad starter, you would be cloning another, you will be linking as a Git module another repository. This is Launchpad core that contains a lot of task definitions for common workflows, as well as Ansible role definitions and some upgrades to Launchpad, an Ansible definition and Helm file release templates definitions. So if you think of Launchpad core as the place for templates and the starter repo as the place for customization, that'd be a good way of looking at it. In addition to these two repos, we also have another repo, which is Helm charts. Helm charts is another public repo where you can find 𝗟𝗏𝗀𝗀𝗀𝗀, Nethermind, and all of the other components that we need to run it as indexers, templated, and made Kubernetes friendly. Okay, so so far you've heard a few things about Launchpad, and hopefully you will be getting an idea of what it is. But if you haven't yet, for today's demo, we have our user, Mary.eth, who will walk us through a full demo. But before I do that, I would like to pause for a second and ask if there are any questions, and specifically, Chris, if there's anything you'd like to add on top of what I've already said.
No, I think yeah, great job so far. If anybody is kind of a bit unsure, there's a lot of new stuff here, so don't worry if things are not totally clear. Hopefully the demo will help. But this is a somewhat complex stack, and you know, you will need to invest some time in understanding some of, you know, the layers and the tools involved. But of course, if you do and work with us on this, I'm positive it will serve your indexing needs very well. But yeah, back to you, Anna.
Thank you very much. All right. So our user Mary has recently heard about the Graph protocol, and she has decided to give indexing a go. So what she knows is that she needs to run the Graph protocol indexer infrastructure, which is the application components that you see on the right-hand side under the indexer infrastructure square. So she knows she needs to run all of these components, and she knows that the indexer hardware requirements just to get you started, so the bare minimum, are to run a 8 CPU core machine with 16 gigabytes of RAM and quite a bit of storage. So she has a machine. It is an Ubuntu 22.04 LTS, and it has SSH access. And she's been looking at the different options to set up her indexer infrastructure, and she recently has learned about Launchpad, and she has decided to give it a go. So let's get started by...
Oh, Anna, sorry, this is kind of my bad. I moved the slides around. Next up is the visualization of the Git workflow, and then the demo of it. But if you would prefer to demo it first, it's up to you.
Okay, I will talk through this first. Okay, so in terms of the things we'll be doing to get started, so for Mary to get started, she will first need to clone Launchpad starter into her own private infrastructure repo. So she would do that with this command of git clone Launchpad starter. Then once she does that, she will need to delete the origin of Launchpad starter so that it has its so that Funtime Infra has its own origin remote set. then once she has done that, once she has removed the origin and added her own origin to the funtime infra, now she has her own clone of her own infrastructure that looks at this point in time exactly like Launchpad starter. The next step would be to initialize the Launchpad core module, submodule, which she would do using this command, the task launchpad update core command. And what this does is embed a copy in her local repo. And once she has once she has pulled the submodule, she can push her changes, and her private repo is in a good state to get started. So let's get started. Let's do all of that, and then we'll come back to the presentation. All right, so can you guys see my terminal?
Yes.
Yes.
Okay, cool. So I will be using our internal docs, so GraphOps docs, to follow all of the steps for this demo. And you will see the docs.graphops.xyz. And specifically for getting started, I will be going under Launchpad and getting started. The first thing you will see here is that a prerequisite for Launchpad is to run at least one host running Ubuntu 22.04. You also need to run SSH access. You also need to have SSH access using public key authentication. And if you're using a Mac, Homebrew must be installed for Launchpad dependencies. So to get started, the very first thing you would need is task file installed. In my case, because I've done this quite a few times, I do have task file. So yeah, you would follow those instructions. Mary will skip them for now. Then we will be cloning Launchpad starter as mentioned earlier. We will call it funtime infra. Cool. And we'll cd into it. And so my branch is up to date with origin main, but this origin main would be of Launchpad starter. So now I would remove the origin of Launchpad starter and will add, actually for me, because this will be an ephemeral repo just for the purpose of this kit, just for the purpose of this demo, I will not be adding this and I will not be pushing it into a remote repo. So I have done all of this. So far we have cloned into the repo, we have gone into the new folder we've created, and we have removed the origin of Launchpad starter. Next step would be installing the Launchpad core submodule. Here, it is suggested to use task Launchpad setup, but if you read this comment, it says this will run two other tasks, so Launchpad update core and Launchpad deps. I personally don't want to run Launchpad deps because that will install every single bit of software needed for Launchpad. So that will be Helm file, Ansible, Helm, kubectl, and a few others. So I already have all of those installed, and I know they take quite a bit of time to run. So I'm just gonna run task Launchpad update core, which will pull the submodule. All right, cool. And at this time, we are able to commit this as being our starting point. Just give me a second to open. 1 second. All right, we're back on. Thank you for bearing with me. So, so far we have updated the 2 repos. We have pulled all dependencies in, and we have installed all of the software dependencies that are needed. Now we are gonna update the configuration with our host definition. So to do that, under my funtime infra repo, I have an inventory directory. In that directory, I have some samples on how to run, on how to set up your inventory, your Ansible inventory with hosts. So in the case of Mary, she's running 1 single node. She has 1 single node. She'll be running 1 single node Kubernetes cluster. And I will just copy her sample and add it into inventory here. And to update it, because Mary is in the testing phases of this project, she's using multipass, which is a CLI to create an VMs for testing on your machine. So if I do CLI list here, you can see that I have 1 VM already. This is the VM that I'll be using for this demo. So this is the IP address that I'm using. So my Ansible host will be this IP address. The port I'll be signing up with will be 22. The user I'll be signing up with will be K0S, and the Ansible user will also be K0S. This is a specificality for multipass. Some of these variables will depend based on how your host is created and who the provider is. Apart from that, so we have specified, we have 2 groups here. We have init group and K0S group. Init group will be for host hardening. All right. So now that we updated our inventory, we can go ahead and apply the base host configuration to all of our hosts. Okay. So you can see as well all of the commands that are being run and the diff of each command, and it asks for confirmation before running. So in my case, I do want to run all of this. Okay. This task will install some apt packages, will create a user if these 2 users are different. So we'll create a main user, a non-root user, and enable SSH config as well as some storage config. Okay. And while this is running, I'm just gonna quickly check the chat. And yes, thank you for mentioning that, Chris. Again, multipass is only used for the demo purposes. we don't recommend using multipass for production-like environments. Okay, this is still running. I'd like to open the floor for questions while this is running. Okay, your time has run out, so I will take that back. So now that that has run, which has created some packages, you'll be able to see all of the code and ask a question about it later. But the next step would be to install 𝗨𝘀𝗲, which is our chosen distribution of Kubernetes, onto all of the hosts. So to do that, we will run this. What we are telling Ansible to do is to give us one cluster of 𝗨𝘀𝗲 with one host as initial controller, and that controller can also run as a worker. In 𝗨𝘀𝗲 and just Kubernetes in general, you have the concept of controllers and worker nodes. Usually the worker nodes are the ones that host all of the different Kubernetes workloads on them, and the controller nodes are the admins of Kubernetes that keep eye on the state of the node and just the overall state of the cluster. So the 𝗨𝘀𝗲 command has run. So now I should be able to export this kubeconfig file, which is the most important file of when to authenticate against your Kubernetes cluster. And if I do kubectl get node, we'll wait a second. It takes a few seconds to come up, but we should soon see our node just like we're seeing it here. So just reading the comment from Matthew, how customizable will this be? For example, it's a very simple example. What if you want to have the user pre-existing by existing automation you already have and not created? You can have that. It works like that. You are not creating. So sorry, just to clarify, in our case, Matthew here, because Ansible user and main users are the same user, I am not creating a new user. So I'm skipping that functionality. And then Kai also said, how well would this work for deploying to existing Kubernetes cluster? For instance, say we have 1 mega cluster in AWS. There are quite a few changes for running that. The changes come from, okay, yes, you're right. I will keep on going and I'll get back to your question, Kai. Okay, so now you can see that we have a node that is ready with the role of control plane, but it is also a worker, which means I can deploy workloads on it. Another thing you can see, our deps task will install this on your machine as well, which is K9s is a tool that very neatly organizes all of the different Kubernetes resources. So what you can see here is all of the current pods that exist in all of the current pods that exist in the cluster. They're all in the cube system namespace. And if I press L on the pod that was selected, I should be able to see logs. It didn't want to show me any logs there. You can also describe the pod to see events, as well as if any errors come up, if a node is not available, if a pod is struggling, and so on. So okay, so the next step would be to start deploying some stuff. Okay, so before you deploy, it is highly recommended that you run these steps for moving your kubeconfig file. This is for security. I will not be doing that because, again, ephemeral VM. So going back to our presentation, we have started at the local environment. We have cloned some repos. We have applied some Ansible tasks with apply base and apply 𝗨𝗂𝗂. We have installed the Kubernetes cluster with apply 𝗨𝗂𝗂. So now we are moving to the next layer, which is the storage, still secret, and monitoring layer, so cluster services. Okay, so to do that, we would run task release apply base. Now, before I run it, I just want to quickly show you. Okay, so in releases, you can see on the apply base that it will be installing still secret, storage, monitoring, ingress, and Postgres operator. And we will also leave K9s running so that we can see how things come up. Okay.
Sorry to interrupt, Anna, but just to let you know that K9s is slightly cut off. Oh, yeah. We're getting some. Yeah, if you could.
Do you mean cut off like this?
Yeah, like if you could.
Oh, I think that in that case that might be as intended. Sorry.
Oh, okay. Yeah.
Okay. Oh no, I see what you mean. It's my there you go. It was my Zoom portion. All right.
Sweet, thanks.
All right, so you can see on the right-hand side that workloads are starting to create just as Helm is installing the different workloads, and you can see the status of the workloads. So in this case, readiness probe is failing, but it's recovered. Okay, let's see. Running Prometheus. Okay, we'll wait for all of these to run. For the purposes of this demo, we will not go into too much detail of each of the decisions of every single application stack, but we will do in-depth demos later on with some of the specific customizations, as well as additional design decisions and how we got there. Right. While this is running, I'm just, while all of these workloads are running, I'm going to show you another tool called Octant, which is very beautiful UI that shows you the state of your Kubernetes cluster. So you have a panel called the cluster overview. Oh, I actually need to change the context here. Okay. Okay, so you can see on Octant each namespace. Okay, so you can see the control nodes, you can see namespaces, it should show them. Let me see if this failed. Okay, so let's look at applications, selecting a different, so let's say monitoring.
I think the VM might really be struggling under load. To anyone who's watching, it's worth saying this entire stack is being installed on the same machine that Anna's actually developing on, which, to be honest, is a bit of a mistake. We, as State Machine has suggested, it would have been better for the demo to provision a remote machine. But yeah, it's I think as it's starting everything up, it's probably struggling, and the Kubernetes API server may not be responding with all of this information.
We'll come back to Octant later on, just to give it a chance to recover. Okay, so I'll stop this for now, and let's make sure that these are coming online. They are coming online. Okay. Yeah, I am getting a warning CPU level. All right, so now we should at least have the monitoring stack, so I can quickly show you the Grafana. So have a look at tasks again. There is an indexer forward Grafana task, which I will be using to open a port forward on Grafana. All right, so welcome to Grafana. We have a bunch of dashboards already in place. Now for this, I just want to show you importing a new dashboard. The dashboard that I want. With the Loki data source. Okay, so straight away, so I imported this dashboard, logs apps. It's a publicly available dashboard, and once you get into it, you can select what app you're looking at. Let's say Grafana. Okay, and okay, and then you can go into the logs. You can also set up more detailed queries as well. So this is for logs. So we can see we've installed Loki. We can look at the different logs. We can create additional alerts. And then once all of the other, sorry, so going back to here, so we have installed all of these. And once we get to the next stack, the Gnosis mainnet, we will be able to have dashboards when those are syncing. Okay. So we have Grafana here. We have Grafana overview, for example. We will make sure to add more dashboards as well. Grafana is persistent. What that means is that since I've imported a new dashboard, the logs dashboard that you can find here now, if I restart the pod of Grafana, this dashboard will still persist by virtue of persistence. Okay. Similarly, you can do the same for Prometheus. You can port forward Prometheus and see different metrics and queries, as well as alert manager rules that are set up. But for the purposes of this, I will not go into too much detail. So the next step would be to so our next step would be to run apply it mainnet or Gnosis mainnet. In our case, we will do Gnosis mainnet. And that will apply every release that exists in the Gnosis, that has been defined in the Gnosis mainnet folder. So before I run that, I just want to have a look at the, I just want to have a quick look at the Helm files. So for Gnosis mainnet, which is what I will be deploying, we need to make some changes. So first of all, we need the JWT key, which needs to be unique. This. Okay, we'll copy this. This needs to be unique and between releases, but also match with the consensus line client. So Nethermind, so Gnosis doesn't currently, hasn't had a merge, so they don't have a consensus client at this time. Okay. This is what I want to change to 10 gigabytes, just for my own limitations. All right. Okay, you should see on this side that Gnosis mainnet is coming up. Okay, so codes are coming up. If we describe them, we can see, okay, successfully assigned, proxy and Nethermind. Nethermind logs. Okay, so coming up slowly. Okay, so once this is becoming, as this is becoming ready, going back to our milestone alert. So we are currently deploying Gnosis mainnet. Once we have deployed Gnosis mainnet, we'll be able to deploy the indexer and then the graph mainnet stack. However, as we know, Gnosis needs to sync with data. So, so for the purposes of this, we will stop the demo here and continue with the demo at a later date. This will be a 2-part demo. So just a quick recap of some of the things we have done before we look at the workload again. So we have created a new repo from Launchpad Starter. We have linked Launchpad Core submodule. These are the 2 main components of your new infrastructure. Then we have set up the client, and with that we have updated inventory with the right IP address. We have installed dependencies. After that, we have deployed all of the base cluster services. So here we're talking about sealed secrets, storage, monitoring, Postgres and Ingress, and we are currently deploying Gnosis mainnet. Okay. And our Gnosis mainnet pod is running. Okay, and you can see, let me make this bigger. You can see that the data is syncing, and as we know, this takes a bit of time for everything to sync. So yeah, this is our stopping point for today. So let's quickly talk about updates and how you're going to keep up with this project, but also how you're going to push your own updates. So for core upgrades, because Launchpad Core will keep on being updated with new components and new version updates, you would run the following commands. So you would again run that task Launchpad update core, which just runs a git pull submodule, and then you would git add and commit and push your changes to your local to your funtime infra imp repo. That is for core updates. Then for starter updates, it's a bit more involved than core updates. You would again start with the task Launchpad pull upstream starter. Then you will begin an interactive rebase to resolve some of the conflicts, and then you'd have to fix all of the conflicts and push into your origin in main. In terms of resources, so the main 3 components of this are Launchpad Starter, Launchpad Core, and Helm charts. Another resource is the docs portal, which there's a link in the documentation, but also I will just very quickly drop that link. Yeah. Cool. And then we are starting a Launchpad office hours, which 𝗨𝗂𝗧, do you have more details on this? Do you have anything extra to say apart from the very first session is tomorrow at 5 p.m. UTC?
Yeah, sure. Just a little bit about the session. So it's going to be kind of like office hours in the truest sense, where you can come with any sort of question around Launchpad, or if you're dealing with an issue, you can come and ask about that issue, and either Anna or Chris can help out with that issue. Or if you're just interested in future releases and discussing Launchpad in general, that will be the place to do it. And as you can see on the slides, it'll happen every Wednesday at 5 p.m. UTC, with the first one happening tomorrow. So that's the extent of the update.
Thank you. We have also created a Launchpad Discord channel where people can ask questions specific to Launchpad, or just post errors, issues, just overall for support and for community resource sharing. Ready for Q&A. Again, thank you to everyone for coming. Chris, do you have anything to add?
No, great job. Let's hop into the questions. So we'll quickly answer the questions that have been in the chat. So Matthew Darwin has asked, is that the first one? I think so. Matthew Darwin has asked, how customizable will this be, or not really meant to be changed? The idea is that it is very customizable. We have that's kind of been one of the design constraints. So a lot of the kind of release definitions, for example, an 𝗟𝗀𝗀 node, and like the configuration required for that, and like the the YAML that pins the chart version and references that, all of that stuff is templated and exists in Launchpad core. And effectively, Launchpad starter is actually the declarative infrastructure. So any releases, for example, would be defined there, not in core. So if you wanted to use the core definitions to make 5 releases of 𝗟𝗀𝗀 with your own release names and service names and everything else, you can. You can also add custom tasks. You can add custom Ansible configuration, and you can add releases and namespace definitions completely outside of what is covered in core. Okay.
Might be worth just to add to that, because I know, Matthew, we've discussed before briefly about load balancing. Maybe if you just talk briefly, Chris, about proxyd and how you can use that to load balance multiple nodes and how it does all the health checking and that sort of stuff.
Yeah. So this is not something we've demoed today, but once obviously the blockchain nodes that you're interested in using are synced, the next step would be to install, much in the same way that this kind of a one-liner, install the 𝗏𝗏𝗃𝗀 namespace. That obviously contains the indexer stack. That stack is configured by default to point at proxyd, which is a layer 7 aware load balancer from the Optimism team. So the whole stack is configured to be load balanced by default. And we're not talking about Kubernetes load balancing, but actually like intelligent RPC load balancing. And in the configuration, you can define any number of nodes and their capabilities. So you can mix kind of nodes with heterogeneous capabilities, some full nodes, some archive nodes, some trace nodes, and it will intelligently route and load balance requests. And you can actually also specify nodes that are external to the cluster. So for those of you that have already synced a Nethermind archive node as part of phase 0, you don't have to start all over again. You can actually use that node in the context of Launchpad by configuring proxyd to point at it. That's something that we can cover in tomorrow's Launchpad office hours. I hope that covered it, Jim.
Definitely, thanks.
Cool. So next question, Kai asks, how well will this work for deploying to existing Kubernetes clusters? Yeah, pretty well. I mean, you kind of see there are really like 2 tool chains here that are, abstracted into just this task interface. But there's the Ansible stuff, which lives behind the hosts task namespace. So for example, task hosts apply base, task hosts apply K0s, etc. If you already have a Kubernetes cluster, you'd obviously just skip all of that. And you would only run the releases tasks, which basically assume that the Kubernetes cluster exists and that your local Kubernetes client is pointing at that cluster, which is pretty much the state that you will be in. So you can use all of this tooling to deploy and manage the stack on top of Kubernetes.
Just to add to that, you can absolutely do that. I will say though, if you need to do that, please do let me know, because there are specific values that need to be overwritten in your release names just to do with the kubelet location. So K0s has a different kubelet location from other public cloud distributions. That would basically be the only change. So if you want to try it, do ping me and I'll make sure to run through instructions with you.
I'll definitely do that. Thank you, Anna.
Awesome. Gemma asks, if lots of indexers use this, are there concerns around decentralization or lack thereof? Or is it so flexible that everyone's stack will still be different enough that one bug won't take everyone down? I think this is a really good question. And, you know, I think it really highlights the dimensionality of decentralization. I think on some level, there is a risk of you know, centralized workflows around any single tool. And you know, as much as all indexers, like this tool is enormously flexible in allowing indexers to run things in their own way. You know, if an update breaks things, you know, that could have cascading effects. So it is something to think about. You know, I don't think it's of enormous concern, but you know, we certainly wouldn't want to see every single indexer using the same tool. Okay. Matthew Darwin again asks, can we script everything so nothing is done manually? I guess this is in reference to Anna importing the Grafana dashboard, which is obviously not a declarative workflow. That's a great thing. We wouldn't recommend that you import dashboards that way, because you obviously don't have that change, that state reflected in your Git repo, and that's the whole point of the declarative workflow. The monitoring stack, as it is deployed, already supports basically doing this declaratively. So you would specify some YAML in the repo that effectively just declares the dashboard, and there's already a controller that would be provisioned into the cluster that picks up on that resource and automates provisioning inside Grafana. Cool. Big Jim has said this is so cool. Thank you, Big Jim. What is happening when the services are coming up? Are the images being downloaded and run like Docker, or are empty VMs being spun up and configured? So this is much closer to Docker in that sense. Obviously, Docker doesn't really have any notion of host abstraction. There's Docker Swarm, which is obviously a separate kind of deprecated product now, but Docker itself just runs on one machine, right? The beauty of this approach is that all of the underlying hosts are kind of abstracted away, so you can add more hosts as you scale, as you index more chains, as you add more subgraphs, and there's this kind of decoupling between your application workloads and the underlying infrastructure that runs things. Okay, and then finally, is there a way to skip installation / configuration of any component? Let's say I already have Grafana. Let's say I already have my Kubernetes cluster with Grafana and Prometheus. Yes. So as to Matthew's question, you can imagine that in core are the definitions of all the important things. Starter kind of just lays out the releases. So you could either just comment out those releases in the kind of declarative release manifest and skip them in this tool, or you could, yeah, just not apply that namespace, but there's no requirement that you need to run everything, whatever you want. Matthew Darwin asks, I assume we can control which load runs on which kinds of hosts. Yes, most certainly, although it's worth saying that that is a feature of Kubernetes and not of Launchpad. But yeah, Kubernetes is, you know, infinitely flexible in that respect, in terms of being able to kind of annotate nodes with labels and then kind of define rules for how the scheduler will take workloads that you give it and allocate them to hosts based on those rules. So yeah, certainly not. No, you definitely have access to those features, Matthew. And then finally, Matthew asks, I assume Firehose Helm charts will be added into this config. Certainly, yes. And with that verbal diarrhea, I will open it up.
Maybe I can make one comment as an early adopter, or at least an early attempter at adopting this, Chris. A couple of things coming from the sort of perspective of a sort of, I guess, traditional infrastructure engineer who maybe hasn't spent so much time with even things like Git. A lot of the work you do in the early stages of this will be learning how to use things like Git properly, because it's really important, especially for when you start wanting to pull the updates from what GraphOps are doing into your own repos. And that's really basic stuff, right? But it's critical in order to be, you basically need to learn Git before you can really decide to deploy this. So I'm hoping that I'm not the only one who is in that position and is learning Git while learning Kubes, and that we can all support each other in the Kubes channel, not just on Launchpad, but on all of the things you need to learn around Launchpad, such as Git. Because yeah, it's absolutely critical that you start. I'm learning that it's critical that you start with an IDE rather than just hacking away at maybe at a terminal or something like that and using Vim Nano or whatever your chosen editor is to edit things in your repo. You really need to be running an IDE. I hope we can help each other with in that channel. Go ahead, Kai.
So we've kept our entire cluster config in Git for since we started our operation. A lot of this you can do without the IDE. The only thing that the IDE really gets you is a tree view of the entire config. That being said, you know, for those that have a hard time using Git, I really, really, really recommend that you take some time to get to learn how to use it, either from the CLI or from whatever your development environment of choice is. But really, the things you need to know are, you know, how to push, how to pull, how to commit, what a commit message is, how to roll back if you screw something up. But it's really not that hard.
It's the rebase bit though, Kai, that I've been learning about today, that to open my eyes to the need for something that's just makes it a little bit more
Rebase. There's an interactive version of Rebase, which if you guys have never used it, we use it extensively in GraphNode development, and every merge to GraphNode is all you rebase off master, and you just squash everything together. It's there's a bunch of good readmes. I'll find some and post it in the chat over time.
Cool. I'd be interested to learn about that. I don't want to use an IDE. I don't want another tool, but I've just been coming to that conclusion in the last week or so that, you know, just working at the command line, although I'm happy there, it seems to help to be in an IDE.
Yeah, I'm diametrically and opposed to the use of an IDE for my own workflow, but so I will do everything I can to stay out of them.
Yeah, we, you know, certainly not forcing an IDE on anyone. That's not part of Launchpad, but yeah, I use an IDE. Matthew has asked a few more questions. He says, if you have a backup of a blockchain database, how do you have Gnosis or Aragon start from backups? Like if you want to scale to another node, then you want a clone of another one and not wait 5 days for it to sync. That is a great question. two things to highlight. The first is that our Helm charts, so I'll link one in the Zoom chat now, the 𝗟𝗀𝗀𝗳𝗂 chart, linked to just a doc section there on restoring from an external snapshot. So the Helm charts already support this. You could obviously have that internal to the cluster via some backup system or served via HTTPS or whatever. So that's option one. If in the kind of latter case where you say, like, if you want to scale to add more nodes and you already have a node in the cluster, that really then becomes a question of the storage technology underlying your node. And we haven't really gone into some of the more advanced options in this workshop, but out of the box, Launchpad ships with the OpenEBS raw file local PV provisioner, which is a mouthful. But essentially all that means is that virtual volumes in Kubernetes will basically be backed by flat files. So there's some location on the host, and it will, provision files, and those are effectively virtual volumes. This is kind of the safest out-of-the-box config. It will work for anyone. But as Anna mentioned, we also support ZFS and LVM, and provide configurations for the OpenEBS ZFS local PV and not the LVM local PV controller, but yeah, maybe we will. ZFS is pretty good. No, this is single host ZFS, Matthew. So this would basically, by using the ZFS local PV controller, your 𝗟𝗀𝗀𝗀 or blockchain node state can obviously then be snapshotted and cloned, and their workflows then for spinning up copies of the node that way. You are asking many questions, but that's not a bad thing. Basically, there are actually implementations of ZFS over the network, which we are looking at, but more for low performance workloads, like for example, just the database that index or service or agent speaks to. You don't need much performance there, so swapping performance for convenience makes sense. But for many of the blockchain nodes, trying to run on network storage, unless you have very expensive hardware sitting underneath, probably isn't viable for some of these workloads. But yeah, you're right. Yeah, exactly, Matthew. And that's why by default we ship with local PV, because you want local NVMe. Yeah, State Machine is saying that there are many storage solutions like Rook, which orchestrates Ceph. And yeah, we certainly encourage people to try those out and contribute. But yeah, at least for blockchain nodes, local storage is the way to go. Will Cohen is asking, will Launchpad also support Btrfs? I would say the answer is you will have no problem using it. Essentially, what I would recommend your path is you provision your host the way that you want. That might be you just install Ubuntu and use Launchpad host space, or you do your own provisioning. Part of once that is done, you then provision Btrfs, right? Like do all of your Btrfs config, and mount your Btrfs volume at some path that is consistently available across your hosts. And then you can use, it's Btrfs? It's not Btrfs?
Everybody calls it Btrfs. I don't know what you're talking about.
But your FS. Yes, that. But yeah, sorry, Cohen. Basically, you just mount your Btrfs volume at some path, and then you configure OpenEBS local raw file local PV to create volumes as files at that path. And that way, you would seamlessly be using Btrfs inside Kubernetes. Kai is saying GlusterFS isn't a bad option for distributed file systems, assuming networking is decent. Do not use it for blockchain nodes. Yeah, it's very few network file. I think unless you're spending very large amounts of money on very expensive storage, yeah, you got to be local. Keep the questions coming, folks.
That being said, Chris, for anyone who has access to lots and lots and lots and lots of money, there are some SAN options out there if you're willing to build out your own localized SAN that will get you pretty decent performance, assuming you set up the I/O channels correctly. If you were to spin up a large SATA array using something like a NetApp filer or something like that, you may get decent enough performance to run an Ethereum node. But really, if you were to hook it up to a 32 gig per second I/O channel through Fiber Channel and distribute that across a bunch of different PHYs, you can get some really cool performance out of that. Just a tidbit from the old days, from my previous life, if anyone has millions of dollars.
Well, yeah, we're running more pleb hardware. So, details on ZFS. Yeah, I think we should end soon-ish. So we probably can't go super deep into that now. But to Cohen's question of is the ZFS integration deeper than just putting flat files on some ZFS mount point, and the answer is most definitely yes. So each Kubernetes workload, and these obviously extend to the workloads and configuration that are available in Launchpad. Each one, basically specifies what's called a persistent volume claim. It essentially just says, I want, a volume this big and of these characteristics. And with the ZFS integration, that PVC will actually result in creating a ZFS ZVol. And on a workload by workload basis, you can customize all the ZFS parameters, everything from record size to compression to deduping to whatever you need. So you can really tune, ZFS for each workload.
Okay, well, if there aren't any other questions, then this might be a good opportunity to wrap. I want to say thank you to each and every one of you for joining us today. This has been a very informative workshop for me. I hope it's been the same for you, and we look forward to having you guys at the next IOH. As a reminder, this will be recorded, put onto YouTube, and if you have any questions, please head over to the Discord channel for Launchpad and ask your questions there. Cool. Thank you, everyone, and we look forward to having you very soon.
Thanks, everyone. Bye.
Thank you, everyone. Bye.
See you guys.
Bye.